Hi everyone, welcome back. Hope everyone are ready for the session. Can I see some thumbs up symbols in the chat session? Hope you loved the first 3 day session of the bootcamp. Can I see some messages spamming around in the comment section? Do share your link to your friends fast so we can start up the session soon. Oh, everyone are busy in watching your IPL matches too. Yeah, after the session, you can continue that. Okay, let's start the session. So, welcome to the day 4 of Machine Learning Bootcamp. So, coming to today's agenda, so in the day 1, we have learned about machine learning and TensorFlow basics. In the day 2, we have learned about understanding data with pandas and visualizing it. And day 3, we have learned how supervised machine learning with TensorFlow with some examples. And we got to know how Kaggle works, and we have done few examples on the Kaggle platform. So today we will be learning about classification models in TensorFlow and regression versus classification, how regression works, how classification works, like what is the use of classification in the machine learning model, etc. Uh, so I call upon the today's host, Moinuddin, to carry on further.
Hello, fam. How are you all doing? So yeah, I'm back with a bang. Here we go. Let's start off day 4, and today we'll be doing classification models using TensorFlow. Also, guys, a lot of you were saying yesterday that we did not use TensorFlow. Yes, that was the agenda. Yesterday we were just giving you an overview of what the framework is. Today we'll be doing a classification model using TensorFlow. So of course, tomorrow is regressor model using TensorFlow, and so on. We'll take over project and start. Of course. So guys, I know a lot of you are watching IPL. So what you can do is come here, take this session, go back and update me on what the score is. So let's get started. So guys, I see the view count is a bit less today. How about you guys share it with your friends, share it in the what do we say, your school college groups, or wherever you like. Say that today we are going to start some hardcore stuff. So uh, just a minute. A lot of people of you are anticipating that today's session will be long. No, I'll try to keep it short. But what we'll be doing is to cut the cheese. We won't code. We won't like write one by one line of code. I already have written a Kaggle notebook for you. I'll run that, explain that line of code one by one, and of course, even if you ask 100 questions in the chat, I'm not going to answer. The question and answer session will be at the last. And of course, if somebody will ask for the attendance link and all, that also will be at the last. So guys, stay tuned. Let's start off with machine learning bootcamp day 4, in which we are going to learn how to make a classification model using TensorFlow. So guys, before we start off, uh, what did we do yesterday? Like, guys, please go back, do a quick recap, and check on what did we do yesterday. And if a lot of people are asking me notes, like a lot of you are asking Kaggle notebooks and PPTs, guys, give us some time of like maybe what do we say, a couple of hours or so, maybe tomorrow or day after tomorrow, we will put all the resources at one place, maybe in one GitHub repository, and share it. So the reason why we are not sharing it one by one is the links might be like jumbled, or you might find a lot of problem uh, to find it again, keep it at a place. So either we'll create a Notion board or a GitHub repository and share it all together at once. So guys, uh, don't worry about all the resources, will be those things will be shared. So guys, today let's learn how to make a classification model using TensorFlow. So moving ahead, as usual, you need not install Python or any IDE or software. Everything will be done in the browser itself. So moving ahead, let's start off our session with a bang. Section 1, let's revise what did we do yesterday. So guys, in the chat, put a thumbs down if you did not come yesterday or day before yesterday or whatever. So guys, put a thumbs down if you didn't come yesterday. Whoops. Yeah, one person is saying feeding data to machine. Yes, we did that yesterday. We also learned something about target variables, something about supervised machine learning. Yes. So yesterday's thing was also doing a classification model. Okay, guys, for the people who did not come yesterday, let me give a very quick revision for you guys. Yesterday we did supervised machine learning, and in supervised machine learning, what happens is uh, there is a lot of data from which there is one target variable, which will be like what do we say, a variable which we will predict. So like whatever model we are making, we will map uh, all the input features to it, to the target variable, and using any of the machine learning model we'll try to predict it. For example, let's say it's like a simple feedback mechanism where you give some input, and the in the output you get some feedback. So that is what we did yesterday. Yesterday we simply predicted uh, what is the type of the car based on the horsepower and the number of seats. So that is how it went yesterday. So basically that was also a classification algorithm, but it was using decision trees. Here we'll use something different, something very different. This still comes under classification, but is a different model. What we will do today. So before you guys get confused, feel like this is going over the board, please go watch the previous videos, and of course share the videos with all of your friends, so that this is seamless and streamlined for you. So guys, once you can give this a quick read, and we'll go to the next slide. Okay, let's move ahead. So guys, section 2, why classification. Even yesterday we did classification, but it was not with using TensorFlow, but today we are going to use TensorFlow. And still guys, the question remains, why classification, why not any other model? So let me tell you why. Basically guys, classification is a technique where what do we say, we categorize stuff. Let's say that there is a mixed fruit basket. From that we are trying to separate fruits. Let's say these are firstly we'll separate them based on their type. Let's say these are the hard ones, these are the soft ones, these are berries, these are like what do we say, bunch of fruits. So based on that we'll simply segregate them. From that we can segregate again, saying that these are apples, these are bananas, these are oranges, these are something, these are something. So basically classification does that. Yesterday that is what exactly we did again. No apple again, fruits. So basically what we did yesterday is classified different kind of cars. like this car is having these features, this car is having these features, and we map those features to the model so that it could predict what is its type. So here something like that is going to happen, but with something else. So let's see what we are going to do today. Moving ahead, so guys, give me a thumbs up if you guys are reading this, and if I could go to the next slide, and if you want to take a screenshot or maybe note this down, or maybe make some notes, I can still put this on. So let me repeat. Basically, classification is nothing, and the reason why I'm repeating this again and again is because there are a lot of people who joined just today, and of course 100% all of these things are going to go above your head. You are not going to understand it. So please go watch the previous 3 days of videos and then come back again. So simple classification में हम क्या करते हैं, we have a few features. Based on those features we classify objects out of a bunch of objects. Moving ahead, and of course whatever we are going to predict is that object which has been classified. So let's go ahead. So basically guys, step one, how does it work? We train with labeled data. Why labeled data? Because of course it is supervised learning, so it involves labeled data. Without labeled data, supervised learning is nothing. So it is unsupervised. So firstly what do we do is train the model. We have a lot of different sort of what do we say, elements in one data set, and the model gets trained saying that, for example, this is a dog and this is a cat. So based on that, what happens is the model learns. It basically sees and understands in what sort of pattern a dog occurs and what sort of pattern a cat occurs, which means how does a cat look like and how does a dog look like. So if you guys have done the captcha thing, how many of you have done captcha, I'm not a robot one, in that it asks you to select some images with some specifications, like select the image with bike or select the image with a crosswalk. How many of you done it? If you have done it, put a thumbs up in the chat. A lot of us, everyone, whoever uses the internet, whoever uses browsers, a lot of you have done it. So, guys, if you are familiar with it, just give a thumbs up, and I'll tell you why is the reason I'm uh, telling that. So, guys, the thing is, uh, we feed a lot of data to a model, and it needs some sort of, what do we say, reference to find out that this particular object which it is uh, getting fed with looks like this particular thing. So just like I said, labels and features. So these features come to or what do we say, are related to this label. So let's say that what the difference between a dog and a cat is, like not more sort of different, because we can easily understand what is a dog and what is a cat, but the machine learning model might not be able to, because if we see in terms of features, a cat has fur, a dog also has fur, a cat has whiskers, some dogs also have some sort of mustache or something. So both have a tail, but their structure is different. Both have ears. Some dogs have pointed ears, some cats have pointed ears. I mean, like, most of the cats have pointed ears. So yeah, of course, tail. So tail, four legs, but the structure of them is different. So based on that, the machine learning model has to identify and deduce the features from that. So what we do is simply take a few features, map it to a simple label, calling that this is a dog, this is a cat. So just like in step 2, I have written that learning patterns are nothing but, of course, features where we take ear shapes, fur texture, facial features. So these are much deeper features, which are like, what do we say, yeah, one person is saying meow meow and woof woof. Thank you so much. What a great observation. So, really great observation. We need more people like you. Please share this with your friends and get more people like you. We need more people like this. Get more 2 to 300 people. So, moving ahead. So based on these things, our machine learning model learns, and like it recognizes a pattern saying that, okay, this object is something like this. So now building a model. So okay, our machine learning model understood that. All right, fine. So this is how this thing is. So what happens is, after it learned, we build a model around it, like not around it, basically that is a model. So we, what do we do is, like, we give it an instruction set saying that, okay, this is a cat, this is a dog, this is how you map the features, and that becomes a model. So today what we are going to do is, we will make this model, keep it at one place, and we will feed testing data to this model. We won't give an input explicitly. So people who are asking some questions like, I'm doing a project, can you help me and all, we will take questions at the last. Please do not spam the chat. We will take all sort of questions and doubts at the last. Okay, thank you. So just like I was saying, once we build a model, what we will do is, we won't give the input explicitly, just like we did yesterday. What we'll do is, when we train, test, and split data. Of course, guys, if you have not attended yesterday's class, you won't know what train, test, split is. So, guys, I will tell it again today while showing you the code. So basically, we take a data set, split it into two. One will be the test. One will be for training. One will be for testing. So testing is nothing but our input. So what we'll do is simply throw this input data to the model, which is like the saved model which we made, and we will try to take one random iteration out of it and see if it is predicting right or not. So that is what we are going to do today, which is in step 3 and 4. We'll be making predictions after building a model. So let's have another example, irrespective of a dog and cat. Let's take yesterday's example itself, taking the type of car. So we will feed huge data with a lot of cars and different types of cars and all, and then we will try to check what type it is. Whoops, sorry, there was a network glitch. So yeah, moving ahead, guys. Mm, this is how it works basically. So just like you saw, uh, those are the labeled photos of a cat and a dog. When a lot of photos, a lot of data, actually data, not just simply photos, but it can be anything. So once we give the model a lot of data, basically what happens is, it um, converges all of these things, converges, and this is like, it takes multiple pictures and takes out a pattern from that. Let's say, okay, this is how a cat looks like. Some person is saying, okay, nerd is saying looks like a neural network to me. Exactly, you're right, this is a neural network. So this is how neural network learns. It takes a lot of things, fine tunes it again and again and again, until it reaches one point where it definitely says that, yes, that's a cat. So that is how neural network works. Like, it works like our brain. And remember what I told on day one, or I think it was on day two, or yeah, day one. Basically, on day one, what I told is, machine learning is like uh, a small baby to which we are teaching. We simply tell it that, this is how you speak. For example, we say dada, tell dada. So slowly it will learn, and at last it will tell the names dada. So that is how it happens. Even this fine tunes itself again and again and again, and then it comes to one response saying that, yes, this is this particular picture. So that is how exactly your face unlock works. That is how exactly object recognition works. That is how a lot of things work. So one person is saying KKR 208 for 7. Guys, uh, I know you are enthusiastic, but let's keep this session only for machine learning, not for IPL. So moving ahead, this is how it works, guys. One person is saying, I have joined today. So please go. Please stay here. Look, if what do we say, you can understand the session, and then go back and watch the other three. You will definitely understand. So, guys, other questions and all, I'll take later, because we should not be killing time today, because there is a very, very long thing to go. So, let's move ahead. Also, let's say that there is only what do we say, one type of, just like I said, car, truck, or bicycle. Inside, if you see that here, there are something called as learned features. What happens is like, basically, what CNN, or what do we say, our classification network, our classification model does is like it. One person is asking, is this CNN? Yes, it is CNN. It is convolutional neural network. So basically, how does it work? So anybody has any idea how does CNN work? Please put it in the comment. So what happens is, it is basically application of different filters. So filters over filters over filters. It what do we say, iterates a lot of filters, and then it comes to one point saying that, okay, yep, this is what the perfect image of this object looks like. So that is when the response comes out. So it is basically pooling a lot of layers to an input. So when a lot of layers and layers and layers are pooled, then what do we say? It what do we say? Applies a series of convolutions, just like I told. Then the output is processed. So if you are not understanding what I'm telling, what will I'll try to do is, I'll put it in a better and easier word, saying with this diagram. As you can see here, I have a car. Basically, this is a car, and slowly what is happening, slowly it is making convolutions, as in, it is, let's say, taking different layers of the picture, and each, by what do we say, layer by layer, it is understanding that, okay, this is how a car looks like. So basically, imagine one person who has never seen something like, what do we say, a UFO. So what happens is, it uh, sees that person sees UFO from all the sides and says that, okay, this is how it looks like. So just like that, if our machine learning model has not seen car any time in life, it goes throughout the car, from pixel to pixel, from layer to layer, and understands that, okay, this is how a car looks like. So that is training part. Now when we test it, it again goes layer by layer, saying that what thing it is it a car, is it a bike, is it what. So again it goes layer by layer and says that, okay, this is a car. So that is how it happens, front and back both. So guys, if you're done with this picture, we'll move on, and I will have another better example for you guys to uh, do this. Okay, just a minute. Yep. So guys, here you go, visualizing neural classification. So guys, what I'll do here is, let's say, I'll I want to scribble on this, but I don't think I can. Okay, fine. So guys, let's say I have a box over here, box number one. Uh, Please don't mind for my handwriting, okay, or else I'll draw a shape. That will be better. So let's say I have a box here, and then there is another box. So in this box, I have to put instead of this, let me use some creating this. In this box, I have to put let's say KKR jerseys. And what else? Which team is playing today? KKR versus what is going on? Can anyone tell me what is going on today? KKR versus what? SRH. Yep. Okay. So here I have SRH jerseys. Okay. So now there is a huge box over here, a huge pile actually. Let me draw that pile. There's a huge pile. Okay. Now this is a pile of mixed jerseys. Now what you have to do is basically from this huge pile of jerseys you have to sort out and take out what do we say, KKR jerseys and SRH jerseys. Okay, so this is a huge pile of mixed jerseys. Let me done. So basically think and tell how will you put a classification algorithm here to do that. Classification algorithm. So what will you do? Normally, you will tell this classification algorithm that this is how a KKR jersey looks like. This is how their logo is, and this is how what do we say, SRH jersey is, and this is how their logo is. So just a minute. Order, send, go back. Done. So from a pile of mixed jerseys, it goes here, and from this they get separated. So this is how it happens. So let me draw the flow as well. Done. So guys, this is how it happens. So from a pile of mixed jerseys, what happens is you separate jerseys based on what happens is the texture, the what do we say, features of each and everything. So let me go deep inside and tell you how it happens. I'll move this algorithm a bit over here. Also, I'll move this here. This one, yeah, okay. Done. Okay. So in this classification algo, what happens is I'll tell you. First, this classification algorithm takes what do we say, texture of the jersey. Then it takes something like texture symbol. Texture. Then it takes something called as symbols or something. Texture, symbols, and color. And what else, guys? Tell me. Give me more example. Mm, give me more examples, guys. What else can it take? Mm, a lot of you are telling sort by color. Okay, fine. The name written on it, that comes under logo. So give me more deeper features, like what do we say, brands on it. Great, very nice. Labels or brand labels and icons. SRH has an eagle icon and KKR has a knight. So all these features, what happens is this our very classification algorithm takes all these features, puts it together, and identifies. Okay, this is this and this is this. Now, how does this happen? How does this uh, bloody classification algorithm understand? Like it is a simple machine, right? It is code. How does this is automatically able to like figure out that this jersey is of this particular this thing. So what I'll do is I'll show you how it happens. So let me grab a SRH jersey first. SRH jersey. Okay, so guys, here you go. Our SRH jersey is here. So once we take this, what happens is I'll tell you. Basically, our neural network. Oops, just a minute, guys. Let me plug in my charger. Yeah. Okay, got it. So, sorry for that. All right, coming back to this thing. So, what happens is here is our jersey. Let's consider this as an image. Let me crop it down. So, let's consider this as our image. So, what happens is here there are on this image. Now, this is our input basically. So, what happens is to on our input there are a lot of convolutions which will happen, a lot of convolutions. For example, just like I showed all the features, it takes a subsample, then another subsample, then another subsample. So just like that it breaks down the image until it understands that okay, this is how a jersey looks like. We'll go back to this thing. uh, just a minute, can you see this? Yeah. So we'll go back to this thing. Just like I said, texture, symbols, color, brand labels, and all of these things are broken down. And once these things are broken down, what happens is forms a sort of it forms a sort of, what do we say, pattern, until it understands okay, this is how stuff works. So guys, convolution is like, what do we say, a bit tricky to understand for beginners. So please don't worry, once you practice, once you take 4 5 another what do we say, practice sessions or something, maybe if you go read some documentation and all, you will be able to understand it much better. So practice makes you perfect. So what we'll do is, instead of wasting time, we'll dive into some uh, real words of hands-on example. So moving ahead, what we'll do today, we'll make a classification model by using TensorFlow and Keras to predict a handwritten digit using the MNIST dataset. So what will happen is basically, I'll write something like this one, and it will predict arrow, it will predict the digit one. So this is what we are going to do today. So guys, understand how this works. Just like we kind of did to the jerseys, what happens is basically our convolutional neural network, it takes this image, takes all the layers, sees how one is formed and how it is, and then uh, tells us what digit that is. Simple, very simple. So what are we going to do is this: we'll take a handwritten number from our test data, throw it inside our ML model, and see what digit will get predicted. So for this guys, I'm using something called as an MNIST data set. There are like a lot of people and it in a very very different way. So actually what MNIST database is, it is something called as Modified National Institutes of Standard and Technology database. So in this database, there are a lot of handwritten numbers, a lot of handwritten numbers from around the world. They have lots of handwritings in which zero is written in one way, one is written in one way, two, three, four, just like that. So uh, let me show you how does this looks like. I'll directly share you the documentation from TensorFlow's website. I'll put it in the chat so that you can go and see how does this look like. So here I go. I've put the link in the chat. You can go see how does this look like. This guy is saying zero has other ways to write. Yes, buddy. A lot of people have a lot of different types of handwriting. So someone has a very fat zero, someone has a very thin zero, somebody's zero has six pack on it. So yeah, there are different ways to write. So of course. So moving ahead, let's do some hands-on coding. Before we start, please try to code along with me. Let's get started. So I'll try to switch my slides to Kaggle. Where is my Kaggle notebook? Present. Okay. So here you go, guys. Kaggle again, of course, and light theme on public demand. So in data sets, in code, my work. Okay, so here you go. Okay, guys. So today I'm not going to consume a lot of time. I also have comments written here for you. I have a very beautiful pre-written just a minute. Yeah, I have a very beautiful pre-written notebook for you, so that I do not write well like code line by line to waste your time, and also I'll explain you everything right from scratch. So firstly, here we import CV2. Also, guys, since day one, a lot of people have been saying CV2, CV2, CV2. Here you go. Here CV2 has come finally. So here now you can feel happy. So also, guys who don't know what CV2 is, it is nothing but computer vision 2. Computer vision is that package which allows you to work with vision related stuff, images, videos. So link to the code so we can implement it side by side. Perfect. Very nice way. Let me throw it in the chat right now. Good idea. Let me put it down in the chat so that you guys can uh, do this along with me. Here you go, guys. Whoops. Just a minute. Not this one. Just a minute, guys. Let me share you the link right away. Hold on, guys. I'm trying to make this a public link, and I'll try to share it. Just a minute, so that you guys can side by side edit this notebook and uh, follow what I'm trying to say. Mhm. Okay, I'll copy this down. All right, till then, guys, somebody in the chat just put a one-liner if you guys know what CV2 is, what is computer vision, and what can we do out of it. And we've got sharp 20 minutes left, so I'll try to explain you code in the given time itself. I won't take any extra time at all. So yeah, some people are saying I have a basic overview. Nice, it's good. So until then, guys, you can go back to the link which I gave and have a look at MNIST dataset. Okay. Yep. So hey guys, here is the link. I'm sharing it in the chat. Here you go. And I've pinned this thing so that you guys can copy paste it. Spamming this again and again. Okay. So guys, here is the link. If you want, you can go. And also there is an option called as copy and edit. You can simply copy. It is just like making a fork on GitHub. So you can go play around with the code, and you can after like copying it, editing it, you can sync same but different, and make some what do we say, as you can go a step ahead, make some advancements to it, give it some good updates or something, play around with the data. It's like your wish. So here you go, here's the link, and let me switch back to my Kaggle notebook. So guys, uh, let me zoom it a bit. So I think this font size is fine for you guys. Is it fine? Font size, guys, somebody quickly, big, small. All right, fine, I'll move ahead. So guys, this what we are doing is here, because we are dealing with images, we import CV2, and here you go guys, import TensorFlow as TF. So finally the day came where we are using TensorFlow to build a model. So let me run it quickly. Whoops, something went wrong. Let me refresh this. Reload. Okay, done. So yeah, let me run this piece of code first. So guys, apart from CV2, there are also other what do we say? I mean, inside CV2, there are other algorithms which are like very interesting, which you guys can go have a look at. There is YOLO. There is YOLO. I think currently YOLO is on V7, so you can check out YOLO. You can check out Coco, and there are also a lot of different algorithms that you can use. So guys, do check out this thing. So yep, done. I have imported files. So here what we'll do is we will use a data set which is pre-provided by Keras. So guys, if you don't know that, there is a separate library which gives us data sets. So let me also show the documentation for it. I think we don't have that much time. So basically, guys, this is one sort of package which provides us data sets. So we need not download the data set again, put it in this Kaggle or Collab notebook, reference the link to it. So all of that time is saved. So what we do is simply we import TensorFlow, and from TensorFlow there is something called as Keras, and there are Keras datasets. So there are also TensorFlow datasets, and also there are Keras datasets. So what we can do is whatever dataset we need, we can simply Google it off and see if that is there on the Keras dataset package or not, and simply import it. So here you go, guys. As you see here, module Keras dataset from this thing site packages is imported. So once this is done, what we'll do is just like we did yesterday, we'll do a train test split on it. So guys, again, I'm telling, if you guys don't know what train test split is, basically we uh, just a minute, we take 80% of the data, 80% of the data set to train the data set, and the remaining 20% is taken as the input to test. Remaining 20% of the data set is taken as the input to test the outcomes. That's why it is also called as out of sample data set, out of sample data basically. So normally what happens is we train with a lot of data. from which from 20% we test, and again we run another iteration by taking some real time this thing. So because today we don't have a lot of time, I'll explain you the lines of code, and then you guys can play around and check out how that can be done. So basically what I'm doing here is I'm loading the data which we got from here. So we got data from here, I'm simply loading this, and on that I'm simply doing a test train split. So guys, you might be asking what is normalize. So guys, anyone have idea what normalize is? Please put it in the chat. I would love to know if you guys know what it is. I'll wait for a minute so that you guys can reply. Somebody is saying extracting features. You're very close. You are like just close. Conversion of numerical values into intervals. Okay, you're very close, but there is one word that you guys are missing. It is normalizing, so there is one word which you guys are missing. Exactly, somebody said scale input data. That is the right answer. So it basically does is uh, what do we say, it scales the data from the range of 0 to 1. All right, so scaling the data points, another right answer. No redundancy also is right. So that is what it does. So what a nice knowledgeable audience I'm catering to. So let's move ahead. So basically what we are doing is, because it is image data, we will normalize it, we will scale it. So I'll run this one, and I have a simple print statement here. Whoops, it was very fast. As you can see guys, almost in less than a second it got completed. That is like very nice. Time is supporting us. So what we do is, here basically once our train test split is done, when the data is already split, what we'll do is we'll try to build a model first. Just like guys, remember the slides before, we will build a model first, then dump data into it, train that model, and then dump the testing data to do some predictions. So here is our model, and guys, these three lines are nothing but the architecture of our CNN model. So as you can see, this NN stands for neural network. And what I'll do is I will get in deep terms of this later. And if you guys know what this does, you have a very good information of what do we say, neural networks. But for time being, I don't want to get into the depths of these. Basically, this is nothing but setting the architecture of our model. That's it. For time being, you can consider it in that way. Okay, so what am I doing here is I'm simply taking a model. Just like guys, you remember yesterday we took decision tree classifier as classifier. Yesterday, yesterday, whoops, we did something like mm, classifier equals tree dot decision tree classifier. We simply instantiated it. So just like that, here we are instantiating a sequential model. So from TensorFlow, we took something called as Keras, and we are instantiating a sequential model. And for guys, what does a sequential model do? If you guys don't know what a sequential model does, is here I have written it in the comments that basically a sequential model is appropriate for a plain stack of layers, where each layer is exactly one input tensor and one output tensor. So basically here we are taking MNIST dataset. Here we are checking the, what do we say, handwritten number. So it means it is like a plain background. On that there is one dark what do we say, image or just a stroke. So here it is like the input is much sort of a plain stack of layers. So that's why sequential is better. So that is the reason we are doing this. And guys, these people are again saying attendance. So please put the attendance in the chat so that people who really want attendance can get quenched. So Yep, there you go, guys. For people who want attendance, here you go. Enjoy. Please fill the form. Others, please concentrate here. I'll also give you a 1 2 line answer on what do we say this tf.kras.layers.dense and what activation.tf.nn does. So basically, guys, what happens is this part creates a layer where every input is connected to every output in a certain weight. So here we are taking dense, what do we say, 128 as let's say 128 units, or basically it's called as neurons because there's a neural network. So we are dividing this into 128 neurons. We can put this higher also based on what we are doing, and also lower, not at all a problem. So tf.nn, this refers to, what do we say, this is actually an activation function to use after computing the weighted sum of inputs. So this basically, what do we say, it is kind of introducing non-linearity into the model. So what is the reason for doing this is it is enabling our model to learn more complex patterns from the data. So what happens is, like, the relu function itself, it tries to learn 128 features, 128 features from like one from 128 units from the given data. So that is how it happens. So every time some data is fed to the model, what happens is, our neural network takes 128 units or 128 neurons to learn from that. So this is basically how we are setting the architecture of it. We can totally customize it 100% based on our use case, but for now this is enough. So let's run this. Boom, it got done. So here what we'll do is, normally just like we did yesterday, we will do model.fit on training data, x train, y train. But here something is different. Something called as epochs is there. So yesterday it was not there. So guys, can you tell me what is epochs? Epochs. Like, a lot of people pronounce it in a different way. So anybody know what an epoch is? Oh my god, all I can see in the chat is attendance form link. Oh my god. So yeah, anybody who knows what an epoch is, instead of 128, can we increase it? 100% we can increase it, but for now 128 is more than enough. So anybody who knows what an epoch is? Each iteration of running it, perfect, perfect answer. Nerd and Kranti Veer, each iteration. So also Ashwin says number of times a model is trained. Yes, very right answer. So number of time the training goes on, training set, exactly, iteration. Right answers, guys. Very right answers. So again, very knowledgeable audience. Salute. So epoch is nothing but, what do we say, each iteration of running this model is called as an epoch, just like I'm saying here. Whoops. Yeah. So as we are fitting the model 5 times for better accuracy, we set it to 5 epochs. I can also set it to 25, I can also set it to 10, but because of time constraint, I'm keeping it 5, because each epoch takes some time to execute. So also 5 is, I think, enough, because for this data set and this level of, what do we say, um, model, I think 5 epochs are like enough. It will give us almost like around zero 0.9 accuracy, which will be good enough. So let's run this. As you guys can see, 1 of 5 is started. So the execution number 1 out of 5 executions is started, and as you can see here, 4 millisecond per step is being taken. And guys, please do focus on this thing, accuracy and loss. As it iterates one by one, accuracy increases and the loss decreases. As you can see here, it was 8646, and here it became 9663, then 9774, then 98. It is increasing, 9846. So done. Nope, another epoch is left, so maybe we will be able to get 0.99 accuracy. Come on, come on, come on, push harder. No, we got 0.98, which means, guys, our model which we made over here is 98% accurate, which is a very good figure, a very, very good figure. And for people who are newbies, you might aim for 100% accuracy, but that is like very, very tough. So 98% accuracy is like very good. So anything above 95 is good, is acceptable, very acceptable. So here, as we took five iterations, each of this executed in 9, 7, 7, 10, 10 seconds. So as you can see, the loss reduced and the accuracy increased. So what we'll do is we will evaluate this model. We will see, array chalo, in here we got this much accuracy, but is it true? So what we'll do is I'll take a variable called as value loss and value accuracy, and what I'll do is use the dot evaluate function on testing data, not on training data. On training data, we already trained it, we already saw these epochs, we came up with some accuracy, that is fine. So on testing data, which is completely new data, which our model doesn't know, with that data, what we'll try to do is evaluate the model and see what is the accuracy. So as I mentioned here, now our model is trained. It's time to check how accurate it is. The evaluate function gives us how much the accuracy is and how much of it goes in loss. So this dot evaluate function over here, this is used to what do we say? Check the accuracy and the loss. So let's run it. Whoops, it got executed in a second. And as you guys see, we've got 0.9757999 something. So almost uh, rounded off to 0.97, which means 97% accuracy. As you can see here, the accuracy is 0.9710 and the loss is 0.09. So very less loss, and we have a very nice accurate model. So congratulations, guys. We built a very nice accurate model, and there is one person who just came. I think he's asking for attendance. We spammed it a lot of times. Please scroll the chat, you will find it somewhere. You'll find it somewhere above. That part is done. So good morning. Moving ahead, guys. So we've got 0.9710 accuracy, which is like very good for us. And let's move ahead to predict something. So what we'll do is I'm importing matplotlib, and what I'm trying to do is on training data, I'm mapping what do we say, one input. So basically, guys, what I'm trying to do here is, you might not be able to understand this suddenly, because what do we say, of a sudden here I took matplotlib. You guys might be like, why this person is taking matplotlib now? So let me tell you what am I doing here. So here I'm visualizing training data. This is like completely optional. Simply I'm just trying to visualize it and see how the training data is, to show you guys how does one input from train, like, or else like one entry from training data looks like. So why am I using plt.cm.binary is because it is basically gives us a grayscale image. So it is just like I said, guys, on a what do we say, blank background or a lighter background, a darker sort of line, or vice versa. On a darker background, a light line is drawn, which is basically a stroke. It's a number. So we a grayscale image is fine. So I'll simply run this. As you can see, we got one entry over here, one image which has been plotted. So guys, can you tell what image is this? Yes, I can use color map for colors. A very good point by Abhigna. I can use color map for colors, but for now, colors are not at all needed. So yes, a lot of people are saying five. Very nice. This is five. We are able to tell that this is five, but our machine also needs to tell that yes, this is five. So let's quickly make a prediction, guys. We have testing data ready, we have our model ready, it's already 10. So let's quickly, very quickly make a prediction and see if our model works or not. So here, guys, what I'm doing is saving this model so that I can use it for later purposes. I am saying it in a what do we say, h5 extension, which is basically the latest way of saying this, saving this thing. So now here goes our code to predict the model. Basically, what we are doing here is, okay, I'll write a markdown one, and here we are predicting, or is like making predictions from the test data. This data was never fed to the model. model because it is like completely new. Our model doesn't know what this data is. So instead of just like we did yesterday, like we took different numbers. So we will do this over here. On X test, we will make predictions. So as you can see, guys, it fed around 313 entries, and I'll try to print the prediction. Okay, we've got some different kind of numbers, which basically even I don't understand, even you don't understand. So what am I trying to do is, guys, I'll import numpy from all these 313 entries. I'll try to plot one entry. So this is not that. There's something different. There's a basic what do we say image which I got from the internet. So I'll remove this. Yep. So I'll run this one first. So here the prediction is 7. So let us see if this prediction is right or not. If the prediction is 7. So to see how was the entry, I'll again run this one. Okay, so guys, is this 7 or not? Because here we got prediction as 7. Is this 7 or not? Yes, of course, it is 7. So let me run this again to see if something else comes. Nope, I'm getting only this thing. So prediction 0, I'll try to take something like 12. Let me check if that works. Okay, 9. So let me run this again. Again, here I'll take 12. Okay, yeah, this is 9. So here it made a prediction saying that it is 9, and here we got the number 9. So basically, what I'm doing here is, guys, actually this should be up. Let me do one thing. Move cell up. Oops. I'll move this cell up. View. Move cell up. Okay, so basically here what I'm doing is from X test I'm taking one value and I'm seeing how the input is. So basically here, okay, let me take the 25th value and see how it looks like. It is basically the number 4, and here I'm making a prediction on the same very value. It was 25th value, right? So 25th value, and I'm here taking predictions. As you can see, the prediction of 24th value, I mean, sorry, 25th value, I'm trying to print it. See, it predicted 4. So from this handwritten digit, it is predicting a what do we say, number. So basically our model works, which means, yeah, kudos, eureka, we got it. So this is how it works, guys. Now if you are what do we say, thinking how to give your input during runtime, and how to, what do we say, get something out of it, I have written one function for you guys. This is like, what do we say, this didn't work for me in the first go, so I am not trying to explain it, but this code 100% will work. The What you have to do is simply fetch this what do we say, fetch this function a path over here. Here you have to put a image path. The reason why I'm not executing is because I'm not able to fetch network images to it. I'm not able to put what do we say, network path into this. So what I'll do is basically um, try to keep this as it is, and here I have mentioned a comment, replace your image path. So make sure you put your path here so that whatever image you put, it will try to predict the digit. And of course make sure it is somewhere from the MNIST dataset, or maybe some image like what do we say, a handwritten what do we say, digit over some paper or something. So guys, so that was the code for today, and let me again give you a quick summary of what happened. Let me give you a quick summary of what happened. Just a minute. Whoops. Can you see my presentation? Anyone? Yes or no? Am I presenting this thing? Okay, perfect. So, guys, basically, what we did is here, just like earlier we did for jerseys and all. What we did is we took training data. Okay, let me draw all the boxes before. and then let me do something. So this is basically our model. Fine. So this is iteration number one. So this is training data. So using training data, we took a sequential model, or as let's take a CNN model only, convolutional neural network. We took a CNN. To a CNN, we fed the training data and trained it. So I'll take an arrow, I'll directly put this arrow to this, and we basically trained it. So after this training, what we did is we basically set some architecture to this model and made sure it was ready. Now what we did, once our model is ready, we took this trained model. Okay, oops, untrained CNN. We trained CNN model. We basically trained a CNN model, and then we fetched some what do we say, test data to it. Test data. Okay, let me draw an arrow. Yep. So what this test data gave us is like, okay, so this untrained CNN became a trained CNN model. So then we fetched some test data to it, and then it gave us a prediction. And what was this test data is, it was a handwritten number. It was a handwritten number from the MNIST dataset. So let me scribble. It was a handwritten number from the MNIST dataset. Oops, it looks like 2. Let me take 7. Okay. And once we fetch this to this, we got the digit 7. So basically, guys, this happened today. So this is the summary of today's session. So guys, so that was all about classification using TensorFlow. So I hope you guys enjoyed it and learned something really really good. So guys, if you really are concerned about attendance, you can scroll the chat somewhere, you'll find it. Please do fill it, and if you have any doubts, I think now is the time. So tomorrow let's build a regression model. Today we built a classification, tomorrow we will build a regression model. And so guys, tomorrow I'll try to start a project or something like that. We'll take a regression model and we'll try to build something out of it. We'll also connect it to the UI, so if possible in time, if it is allowing me to do in time, we'll try to do it. So but definitely I'll teach you regression, and if it is allowing me to connect to the UI and explain you this extra stuff and all, I'll try to do that. So before leaving, guys, please fill up the attendance. It will mark your attendance for day 4. And people who are joining today, you need not worry, you can continue this thing. uh, Moving ahead, guys, if you have any questions, this is the time. I'll stay for another 10 minutes sharp, because even I have to go, I have to sleep. I'm a human, I'm not a machine learning model. So guys, yeah, please, questions. How can we decide the number of epochs while training? So that depends on a lot of factors actually. Let me tell you some of this thing. Also before that, some person asked, um, just a minute. Just a minute, guys. Let me take all the questions one by one. Please don't spam. Let me take all the questions one by one. Okay. Let me check what all you guys are texting me. Okay, so guys, firstly, the reason why, okay, what was the question? It was how many epochs, right? All right. So as you can see, the what do we say, notebook. What we did is, before Mm, taking the epochs, we trained our model, and while training itself, we will try to understand how much is the data and how much hardcore the data is. So if it is like a very simple data set like MNIST, it will, 5 epochs will be enough. So if it is something like very what do we say, much deeper data set, like what do we say, detecting faces, detecting objects, so that will take more epochs. So there are, I'll give you basically 2 to 3 what do we say, generalized reasons. One is monitoring of training, like what do we say, loss and accuracy. Based on this we can decide how many epochs to be taken. If you think that your ML model will have low accuracy, you can simply calculate the accuracy and then increase the epochs as well. So that is one point. Another point is uh, learning curve. So I'm not talking about our learning curve, I'm talking about the learning curve of the model. So if you know that the data is just like I said, it is much deeper, it is like object detection, detecting of some what do we say, complex objects, then significantly you can increase it. So you can experiment, you can completely experiment, you can try pushing it up to 20, you can try pushing it up to 15 or something. That's totally fine, you can experiment. Okay. Hmm. Any other questions? Okay, what is CM in Matplotlib? Okay, basically color maps, guys. So color map, I'll tell you what color map is. So let's say that, I hope you guys know RGB values. When all the RGB values are what do we say, of some, what do we say, if R is higher, G is 0, B is 0, that is basically right. So just like that, color map is one sort of, what do we say, function in Matplotlib which allows us to set the color. So color map actually, not just the color. So if I tell the textbook example, uh, CM provides you large set of color maps. Large set of color maps, all the functions. It is actually called as a mixin class, MIXIN, mixin class for what do we say, color mapping. So what do we say? It is basically scalar mapping. Right, exactly. So scalar mapping of colors. So here we took what do we say, color map to make it grayscale image. So let me go back to the code and see. We took cm dot binary. Binary means 0 and 1, so basically grayscale image. So you can go to Matplotlib's what do we say, documentation, and see what else is given there, and basically play around with the code. Any other questions, guys? Some people are saying URL fetch error, some people are saying dataset is not fetching. So guys, do one thing. uh, Try to import, try to do simple things like, what do we say, 100% it should actually import. So do one thing, try to reload everything, and try to what do we say, start executing from the top to bottom. Top to bottom in the sense, first import TensorFlow, try to like, what do we say, restart the notebook completely. There'll be something called as restart the kernel. So restart the notebook completely and try to execute from top to bottom. So that will help you. On what basis did we took 128 in okay, so guys, 128, just like I particularly explained what is 128, so I'll explain it once again. 128 is the number of neurons, or number of the units we are trying to take. Just a minute, somebody saying pip, no, pip install is not needed. And okay guys, if you really want to do, give it a try. You can pip install TensorFlow before importing it, but it is basically not needed in Kaggle. So try doing that. If pip install is not working, I'll tell you what to do. Just put an exclamation before pip and then do this pip install like this. So, and if you are doing with uh, Collab or Jupyter Notebook, then 100% you have to install. Damn sure. So yeah, guys, I'm coming back to the 128 question. So basically, 120 is nothing but density. Density in the sense like 128 uh, number of units or 120 number of neurons are being taken to uh, what do we say, fill up the input data. 128 number of neurons, 128 different features are taken from the input data. So basically, let's say there is this image on the screen. As you can see, you can see Q&A, you can see TensorFlow user groups logo, you can see Google developers logo. So if I take one particular grab of this, from that 128 different features are deduced, so that can be increased. And based on what is this taken, there are multiple things. For example, let me give you 2 to 3 things. So number one, what do we say, it is based on what sort of data you have. Here we have very simple data. So if we have complex data, we have to take more. So just like I said, also, and why 128 basically is it is often selected because the complexity of our task was less. We took 128, and also computational resources should be kept in mind. If you have a very nice GPU or a very nice TPU, tensor processing unit, then you can take more, because this was a very basic task. It was just detecting a stroke and saying what is it. So if we have huge sort of data set and very deep down, what do we say, work on that, then you can definitely increase it. So complexity of the task, and if you want to experiment around it, and of course based on your computational resources, as I said, more neurons require more computational power. In Kaggle, still getting URL fetch error. Can you please copy down what is the error and paste it in the chat box so that I can see what it is? In Google Colab, it is working. Fine then. Wherever it works, it's fine. So really, I don't know what's wrong with it, because until you don't copy paste the error, I cannot be able to figure it out. So somebody is saying, very nice explanation. Thank you so much. Thank you so much. Thanks for your feedback. It is very well appreciated. So yeah, guys, it is almost 10:20. Any other question, guys? Okay, if you have no other questions, we can end today's session. So, hope the session was very resourceful, guys. Thank you so much for joining. Tomorrow, let's aim for bigger audience. So, guys, please uh, go tell your friends, share that TensorFlow user group in collab with GDSC is doing a very nice bootcamp. Make sure they go visit our channel and see the previous videos and all. So if you don't know what it is, I'll basically tell you how you can watch our videos. let Let me present my screen and show you where you can watch our videos. So just a minute. Yeah. So guys, here is our channel. If you can simply search for TFUG Hyderabad. Uh, I think on the first one itself, you will be able to find our channel, and here you can watch, not in the home, in the live section. You can watch all our videos, day one, day two, day three, day four. So all of them are available on YouTube forever, as long as our channel stays. It is like available. You can go watch day one, day two, and day three and day four, and then come back. And if you don't, what do we say, watch everything in deep, you can have a basic understanding and come back to the fifth session. Also guys, one small surprise for you all. If what we are planning to do is, if you have, what do we say, attendance in 4 day streak, also we are planning to give you out certificates, because a lot of people are joining very recently. So if you missed day 1, 2, 3, no problem, no problem at all. From today, maintain a streak so that you will be able to get a proof of attendance. and from our side we'll give you a lot of resources in through maybe a drive link or through maybe a notion board or maybe a github repo or something like that. So one uh, somebody is asking, do we have to remember all the codes? Remember as in, see, once you practice you'll definitely get on with it. You need not worry about that. You need not mug up it. So once you practice, keep practicing it. Try like what do we say, going inside the code, playing around with it. Until then it'll be fine. So somebody is getting trace back most recent call last. Try to put the whole error, like trace back most recent call last is only one word, so try to put like a bit much more part of the error. mm. So basically that error comes when you like when there is a socket problem actually. mm. Did you try it after signing? Cannot post. Okay, so let's do one thing, guys. We have a community where we have a separate chat group for doubts and questions. You can post it there. You can also post the screenshot there. You need not worry. Somebody, any of our volunteers or someone or me itself, tonight or tomorrow will try to solve your question. Or else, please try to Google it. Copy the whole thing, Google it or Chat GPT it. That is a very better way of uh, doing that. So that is also one thing. Any more questions? So also, guys, can any of the uh, volunteer please put down the group chat link so that they can ask questions if somebody is not there in the group chat. So please put it down. Okay, we have one question. Rahman is asking, in our code, optimizer equals Adam. Does it like a hyperparameter? Actually, it's an optimizer. So basically, our neural network needs optimization. So what we do is we use something called as Adam. Adam stands for adaptive moment estimation, if I'm not wrong. Yes, adaptive moment estimation. So what Adam does is just like to keep the momentum going in the right way. What it does is it represents the best solution which has the lowest error. So it optimizes the neural network internally. So you need not explicitly use optimization functions and all. So Adam does that. So Adam is something which is like used in a very what do we say, often. It is used often. So Adam is like good one. So that's why I used it also here. Also, there are a lot of other optimizers as well which can be used for experimentation and all. So guys, here's the chat link in the chat. So guys, we are 25 minutes past the live. So a lot of you have been there for a very long time. Thank you so much for staying. So I think this is the place where we have to say a goodbye. So let's meet tomorrow at the same time. And if you are uh, joining today for the first time, please go to our channel, subscribe our channel, please, so that every day when we start a live, you get a notification and you don't miss any update from us. So guys, irrespective of the events what we do, we share a lot of other knowledge as well. So please do stay tuned. A lot of things are coming up, and a special announcement tomorrow. We are going to kick off one sort of small project where we'll be participating in ML Olympiad. So tomorrow, guys, please definitely join. And also maybe soon in the future we'll plan up something called as a ML study jam, which will be a month long program where you will learn every single corner of machine learning. So it is a month long program. Each week we'll be having 3 to 4 classes and a lot of assignments as well. So it is like a very good, resourceful thing to join. So it is coming soon. So please do go follow TFUG Hyderabad and almost all the GDSC chapters, whatever uh, is like in your region, in your college, whatever GDSC chapter is, go follow them. So which will get you into this bubble where we are spreading knowledge like confetti. So guys, thank you so much for joining today. It was very great talking to you guys. Hope you all have a very good night. Thank you.